Alright, so the next thing we're going to talk about in the 1.4 is determining when a function is increasing or decreasing. And for the most part, we are going to do this graphically. Now, sometimes that will require us to actually get our graphing calculator out and graph stuff. So, again, maybe you should have your graphing calculator out because we are going to look at a few things graphically. We're going to figure out how to find maxes and mins and increases and decreases. Alright, so just first of all, the definition of increase and decrease. A function is defined over an interval I just means some interval. Usually we talk about its domain, but we could just be a piece of the function if we wanted to. x1 and x2 are values in the interval, again, usually the domain, but we don't necessarily have to limit ourselves to the domain. If the function's increasing over that interval, and that means for every x value, where again, I start at 1 and go to 2, so 2 is the bigger x value, so I'm increasing from x1 to x2. My function values are also increasing. When I plug f of 1 in, it's less than f of 2, so then my value at the bigger x value gives me out the bigger y value. The picture that goes along with this, the easiest way, so I've got, again, my x, my y's. So x1 would be something like 2, x2 would be something like 10, right? x2 is bigger than x1, right? That's this part. Then I plug x1 in, and that would give me out my function value, let's say 1. And then I plug in my 10, and that would give me out my function value 6, right? 6 is bigger than 10, right? My function value at the bigger x value gives me out my bigger y value. Whenever that happens, I'm increasing from 1 to 2. My function increases. Decreasing is the exact opposite of that. I'm decreasing over an interval I if, as I plug in bigger x values, I go from x1 to x2, which is bigger, the opposite happens. My function value at the first value is bigger than the function value at the bigger x value. So this time, when I plug in a bigger x value out, I get a smaller y value. And so it's the exact opposite. So suppose this is my x1, which is, say, 2. This is my x2, which is still 10. But this time when I plug 2 in, so I keep saying 2 because I put x2, I get out the bigger number. Suppose it's 10. And then when I plug 10 in, I get out a smaller number. Alright, so again, this would be f of x2, the y value. This would be f of x1, the y value. When I plug in the bigger x value, I get out the smaller y value. Whenever that happens, I'm decreasing. My function's moving down, so I'm moving in a decreasing fashion between my 2 points. Alright, so I'm decreasing. They give you a nice illustration in the book, so I went ahead and popped it here. So again, this is just another, basically is what I just talked about. If I'm moving left to right, and the graph is moving up, right, again, left to right means I'm picking bigger x values. If I pick bigger x values and they plug in, and when they plug in they give me out bigger function values, I'm increasing. The opposite's true, I'm decreasing. When I plug in bigger x values, but my function values come out smaller, right, this would be smaller, I'm decreasing. And again, they kind of do uphill, downhill. Increasing, decreasing should be something that's fairly intuitive, right? If I'm moving up, I'm increasing. If I'm moving down, I'm decreasing. The steepness is, again, what's changing. The steeper it is, the bigger my slope would be. The less steep it is, the slower my slope would be. All right, so I'm going to look at a couple examples. So the first one, here's a cubic function. So you graph this out on your calculator. So given a graph of this cube, so this is the function 4x minus 1/3. So it's nonlinear, right? Not a line. And so increasing and decreasing is changing. My slopes change. I go from positive slopes to negative slopes, right? Negative because I'm decreasing, positive because I'm increasing, negative because I'm decreasing. And they're all different, right? Because it gets steeper as I go down. And so looking at my graph, the biggest points are when it changes. These are what we call turning points. Alright, so we have our turning point, meaning it's turning direction. And these occur at the maximum or minimum points, which again we can use the calculator to find them. And so this one, we have a max here at x equals 2. We have a min at x equals negative 2. And so those Those spots, I'm actually stopped. I'm neither increasing nor decreasing at those moments. Slope would be 0. Before the -2, I'm decreasing, right? I'm decreasing here. I stop, and then I increase. Then I stop again, and I turn, and I decrease. Between the stopping points, right? These would be the stopping points. I'm either increasing or I'm decreasing. And so that's what sort of, again, is described down here. We always use interval notation. Right, so the solution is, when is this function increasing? When is this function decreasing? Well, it's decreasing at the tails. All right, from -infinity up to the minimum at 2, -2, right? -2 is the x value. It's decreasing. Right, then it increases for a little while, and then it stops at 2, and then after 2, it decreases again. So from 2 to infinity, it's decreasing. So so if I'm on my function on the interval -infinity to -2, I'm decreasing. Or if I'm on my function between +2 and +infinity, I'm decreasing. There's only one small part of it that's increasing, and that's between the 2's, right? That's it. That's the only place where I have positive slopes where I'm increasing. And so I'm increasing between the 2's. From -2 to 2, I'm moving up. My slopes are positive. You put parentheses because at the 2's, you're not doing either one. Right? At the 2, you're actually stopping. So the slope would be 0. It wouldn't be positive or negative. It's 0. So there's no increase at 2 and -2. Right? It's a flat stopping point there. If you look at sort of, again, it's stopped. You had a line that touched it at that moment. Alright, so we're going to look at a few more examples, and we're going to do these graphically. Now, there's a few ways you can graph it, so I'm going to figure out increase and decrease, and we're going to solve graphically. Alright, so I'm going to go to my calculator and type in my absolute value. Alright, so I'm popping up my calculator here. So remember to graph. We hit y equal. Remember, absolute value is under math, over to number, and it's the very first one, ABS. Alright, so I select 1. And then we type in our function. So our function was, 2x minus 10. Alright, so 2x minus 10. And then I'm going to check to make sure my window is big enough. So I'm gonna start with a standard window. I may have to go bigger. Alright, so again, I'm going to go to window and standard. Standard, I'm just making sure that I'm at 10 by 10. If I wasn't, I'd go to zoom and I'd select standard. Alright, I'm ready to graph. Let me see, I forgot my x. Typing it out on a computer. There we go. Now I'm ready to graph. There's my function. Alright, so it's the V shape. And what I actually have to figure out is, well, what is this turning point? Alright, so I have to figure out my turning point. So to figure out the turning point, what you have to do is, well, it's a minimum, right? So it's coming down, it's a minimum, it's going up. And so where you do that is, on the calculator, it's under, you're doing calculations, but you have to hit second trace. So second trace, and then I want to find a minimum. Alright, so I select 3. And then the calculator asks you to do some stuff. It asks you to go to the left of it, and so, where's my cursor? There it is. And so I make sure you're to the left of it, so don't go past it. So, I mean, the closer you get, the quicker the calculator is there. I'm to the left of it. Hit enter. Alright, then go to the right of it. So again, I make sure I go past it. So I make sure I'm past it. There, I'm past it. Hit enter, and then it's up to you if you want to guess. Again, if you move it closer to that point, it just makes the calculator work a little faster. Alright, and so it's at, actually, the calculator's a little flawed. It actually is at 5, right? 4.99999 is 5, and the y value is 0. Alright, so and you can check it to make sure that it is 5. If I plug 5 in, it should get 0 out. Alright, plug 5 in. And if I get my x value of 5, 2 times 5 minus 10, it's going to give me 10 minus 10, which is absolute value of 0, which is 0. And so it is at the 5. The function comes down. At the 5, it stops and then goes up. And so my graph is decreasing to the 5 and increasing after the 5. At the 5, it stopped, right? Neither increasing nor decreasing. Alright, so to write that out, of x is increasing, we always use interval notation, from negative infinity to 5, don't include the 5 because that's where it stopped. And I did that backwards, guys. Sorry, that's where it's decreasing. Let's try this again. It's decreasing from negative infinity, right? This is where it's decreasing from negative infinity to 5. At 5 it stops, and now I'm increasing from 5 to infinity. So increases from 5 to infinity. So make sure you change that. Decreasing from negative infinity to 5. Increasing from 5 to infinity. Don't include 5 because that's your turning point. Alright, next example. I'll give myself a little more room to work than what I have here. Alright. So again, you could graph this out on your calculator. So go back here, clear that out. Clear. And then type in x squared minus 4. So, here, x squared minus 4. I'm going to do a standard window. So I'm just going to hit graph, and there it is. Alright, so same thing, I'm going to need a minimum. Right, my parabola is opening up, and I want to figure out this minimum. Looks like it's at, and it is at 4, 0, 4, but again, just to make sure we practice how to do this on the calculator. Hit second trace 3. Alright, go to the left of that value, hit enter, then go to the right of that value, hit enter, and then I'm just going to hit enter again. Alright, the minimum is at, and again, the calculator's flawed, but it is at 0, negative 4. So to graph this out. So 1, 2, 3, 4. Now you can check it out. If I plug 0 in for x, I get negative 4 out, and that's the vertex. Which means it's decreasing again from negative infinity to x equals 0. That's the x value. And so I'm decreasing from negative infinity to 0. It's the x values. I'm increasing from 0 to infinity. I'm moving up between the x values 0 to infinity. Alright, next example. Alright, this is a 4th degree function. This is going to be a little more complex. So again, type it in the calculator, so clear that out. It was 0.25 x to the 4th. So x raised to the 4th minus 2x squared. And I'm going to start with a standard window, see if I need to adjust. I don't. Alright, so it's a W shape. So I've got 3 turning points. So I'm actually going to find a minimum, and a maximum. And actually the minimums occur at the same value, so I'm only going to find one. It's symmetrical, and so the other one will be here at the opposite side. So second trace. I'll find the maximum first. Looks to me like the maximum is at 0, 0. Alright, so check to see if it is. So enter. It's left of it, right of it, guess, enter. Alright, and it is. Alright, maximum is at 0, 0. Alright, so drawing this out. My maximum here is at 0, 0. There's a minimum and a minimum I have to find. And I'm only going to find one of them, because like I said, the other one, and you can look at the other one on yourself, but I'm just going to find one of my minimums. So second trace, 3. Oops, too far. it is. The minimum's at 2, -4. It means the other minimum's also at -2, -4. And you could do the same thing on your calculator to verify it is, but I'll leave that for you to do. But this minimum is at 2, -4. This minimum would be at -2, -4. And so the x value is -2, x value 0, and this x value would be +2. Alright, so decrease, switch to increase, switch to decrease, switch to increase. Alright, so they both have two places. There's two places it's decreasing and two places it's increasing. Alright, so it's increasing from the x value -2 to the x value 0, or from the x value +2 to infinity, right? This is infinity. It decreases from -infinity up to the -2, so -infinity to -2, or this piece here from x equals 0 to x equals 2, so 0 to 2, it's decreasing, right? Decreasing, increasing. Alright, so there's two places. The blue spots, it's decreasing, the yellow spots, it's increasing. And it always goes for the x values. Over what x values am I increasing, over what x values am I decreasing? Always use interval notation, and remember, at the turning points, it's stopped. So don't include those. Use parentheses. It stopped at 2, it stopped at 0, and it stopped at -2. Meaning the slopes at those points are 0, neither increasing nor decreasing, because it's switching directions. Alright, we will stop there with this particular video on increasing and